The points A, B, C and D form a quadrilateral ABCD. Show that AB equals AD. Find a vector equation of the line A through A and the midpoint of BD. Show that C lies on the line found in part 2. And what type of quadrilateral is ABCD? So that's the question then. Here it is here. So AB first of all then. So the modulus of AB, use Pythag, A to B will be. So the difference between these is 2, so it's 2 squared. The difference between 2 to 4 is another 2, so that's 2 squared. And then 1 to minus 3 is a difference of 4, so that would be 4 squared. 16, 20, 24, so that's root 24. And then AD is equal to, let's have a look at AD, A to D. 1 to 3 is 2 squared. And then 2 to 6 is 4 squared. And then 1 to 3 is 2 squared. Which is again square root of 24 because it's the same constituents, isn't it? Just in a different order. So 16, 20, 24. So AB is equal to AD. So that's part 1. Find the vector equation of the line through A and the midpoint of BD. Okay, so part 2. So A, the coordinates of A, let's just get those. 3, 2, 1. And midpoint of BD. The coordinate of that midpoint of B to D. Midpoint of BD. So add these. 5 and 1 is 6. Divide by 2 is 3. And then the next coordinate. 4 and 6 is 10. Divide by 2 is 5. And then the last one. Minus 3 plus 3 is 0. Divide by 2 is still 0. So the line through this then, as a vector equation, is equal to A 3I plus 2j plus k plus lambda times 3 minus 3 is 0. And then 5 minus 2 is 3j rather. And then 0 minus 1 is minus k. So let's just check that again. A, 3i plus 2j plus k, plus lambda times the difference, the directional vector from A to the midpoint is 3, take 3 as 0, so there's no i's. 5 minus 2 is 3j, 0 minus 1 is minus k. So there's the vector equation of that line. Show that C is on this line, so C is 317 minus 4. So part 3, C has coordinates 3, 17 and minus 4. So let's have a look at this then. Lambda 3i, yeah, that would give that. 2j plus 3, so 2 of these plus 3 lambda equals 17. So we can see lambda must be 5, mustn't it? 15 plus 2 is 17. So lambda is 5. That's easy to see. And then minus 4. Minus 4 needs to equal 1 minus lambda, isn't it? And that equals 1 minus 5, which equals minus 4. And 3 equals 3 for the I component. So that's already taken care of. So C is on line, or on the line. Okay, so that's part 3. What type of quadrilateral is ABCD? Okay, so you've got A, B, AD, AB, C, D. So AD was the same, wasn't it? And these two were the same distance. Okay, and then what else did we get? Show that C is on this line, midpoint of A, B, D. Find the vector equation of the line through A and the midpoint of BD. So the midpoint of BD is here, and we have a line here. And show that C is on this line, which we did. Okay, so we got something like this, and there's BC and CD. So we can see this is a kite, can't we? So part 4 then, ABCD is a kite. ABCD is a kite.